This is the second part of lesson 8.7, graphs of sine and cosine. Okay, we're going to go to the next one down here, and it's graphing both the sine and the cosine function together. So why don't you pause the video? You're going to graph both of these on the same graph, and so just use two different colors, or you can highlight one with one color and highlight with another color. Okay, this is what your graph should look like. People sometimes ask, like, do we need to do the whole wave? Could we just do like this much of it? It just depends. You want to show enough that it looks like you know what you're talking about, that it fills the graph if possible. You don't want to just have, half of it, not even showing. Like, if we just cut it off, that kind of looks lame. So you have to show, at minimum, an entire cycle. But if you have a lot of graph left, you need to show a couple different cycles. Sometimes it's going to be so spread out that you're maybe going to be able to show one cycle in a graph, like if it's really stretched, that way, then you may not be able to show an entire cycle. But sometimes it's compressed and maybe you can show an entire cycle like in a very small space. In that case, you need to do quite a few cycles so that we can see all of it and it looks, normal. Okay, this is our first transformation graph, and it's going to be cosine, so that's going to be our parent function, and it has an amplitude of 2. So let's write that down, because one of the things that you're going to have to answer on all of these is what's the amplitude. It's always positive, and it's that number in front. The next thing you need to make sure that you know for each function that you graph is what is the period. So in this one, it's going to be 2 pi, and then divided by, there's a 1 right there. And so divided by 1, so that's just 2 pi. So this is going to be the standard. It's not going to be compressed or stretched horizontally. So when you do these, the first thing that we need to do, especially where you're just starting out, is we want to graph the parent function. So let's just graph the cosine. So I'm going to graph this starting at 1 because cosine at 0 is 1. And then because my x-axis is the same as what we've been doing, I can just copy what I've done on the other ones. So graph the parent function. So pause the video and graph the parent function on your graph. Okay, now the next thing, how do you deal with the amplitude? So the amplitude, this just means it's stretched twice as much. So it's going to be stretched in that direction and in that direction. And so as you deal with this, what you do, it's not too hard. You just take the high point, which in this case right there is 1, and you're going to move it up so that it's at 2. So instead of being at 1, it's going to be at 2. Instead of being at -1, it's going to be at -2. Instead of being -1, -2. Instead of being +1, +2. And so 0, 2 times 0 is still 0. So your zeros are still there. And so now what you're going to do is you're going to do a new curve. And you're going to still cross the zeros when you get to the zeros, but you're going to go all the way up to 2 and all the way down to -2. And so it's twice as stretchy, I guess. Now the amplitude is still just 2, and it's basically how far is half of that wave length. And so it's a distance of 2 from the high point to the midpoint, I guess. And so that's what the amplitude is. So our entire graph of 2 cosine theta, which is this one, is the red. And so a good practice is just to highlight it. I think it's a really good idea to have your parent function on there because if you have to do a couple different transformations, it really helps you follow through all of them. And then you might have a couple different graphs, and so you want to highlight your final answer. So you need to get a highlighter, you need to highlight that final answer so that even though there might be other things on there, we know which one is the final. Please be aware of what your x-axis says. Now so far I haven't changed that on you, it's all the same so far. But we're going to see in just a minute how it can be different. Okay, the next graph that we're going to do is we're going to do y equals sine x minus pi fourths. So a couple of things to notice. First of all, we're using x instead of theta. That's perfectly fine. Again, it's just an input variable. Okay, the next thing, something like this was not mentioned on our definitions on the previous page, but we have seen something like this before. This right here, this tells us that there is a phase shift. And so just like we've learned before, this means that it's going to go right pi fourths. And so pi fourths on this graph is 1 square. So basically our sine curve is going to shift 1 to the right. There's no change in amplitude, and there's no number here. So there's just a 1 right there. So if there was like a 2 right there, that would be a period change as well. But I'm trying to ease you into this carefully. So let's do the parent function for sine first. So we're just going to do y equals sine x. So remember that at 0, sine is 0. And so we're going to just go up to 1, down to 0, down to -1, back up to 0. And then let's go in the other direction as well. Okay, so that's our parent function for sine. Now what we're going to do for our phase shift is we're going to move everything to the right pi fourths. So what's at 0 is now going to be 1 square over, because that's pi fourths. This high point at 1, it's now going to be right there. Okay, this point at 0 is now going to be right there. This point at -1 is now going to be 1 to the right. So that's all we're doing, is we're just moving everything over. And so it's still like taking 2 boxes to get from, you know, one marked point to the next. So like that. And so you can keep going like this 0 right there, it's going to be right there instead. So you can just keep going. And so everything is just shifting to the right. Like that. And then that's all you have to do in this one. There's no other transformations that take place. So I'm going to highlight this curve as my final answer. And that is the graph for y equals sine x minus pi fourths. Okay, the next one we're going to do, there's 2 things going on here. There is a phase shift. Now this time it says pi halves, which in this graph, that's 2 boxes. And then it also says that we have an amplitude. So it's going to be stretchier. It's going to be going higher and lower like that. And so we really just need to deal with one thing at a time. So the best way to do this is deal with your amplitude last. Okay, that's the last thing you want to do. You need to deal with other things first. If there's a change in the period, you need to deal with that first. Deal with phase shifts, or if there was a +2, or something like that. So if there's other things, you want to deal with all those things first. So the first thing I'm going to do is do my parent function. So I'm going to remember sine, it starts at 0, like that. And so just quickly do your parent function. With parent functions, my idea is that you should know the parent function very well. You should be able to identify it. You should be able to draw it very quickly, not have to stop and think about it really hard. Okay, the next thing we're going to do is we're going to deal with the phase shift. Now this says plus pi halves, and so as we know from prior experience, that means it's going to go left pi halves. In this case, that's 2 squares. So I'm going to take this point and it's going to move there. This one is going to move there. We're going to move everything over 2. And so that's what I'm going to be doing. So everything's going to move left 2. So I'm going to start with my graph and just start doing it. I'm just moving over 2. It's still taking 2 boxes horizontally to get through the +1 to 0. Okay, now that's not my final answer. I have not dealt with the amplitude change yet. I have dealt with the phase shift. Okay, now the amplitude on this one is 2. That means it's going to be twice as high and twice as low. So here again, I'm going to take my 0 right there, and instead of being at, well, 2 times 0 is still 0, okay? This right here, instead of being at -1, is going to be at -2. This point right here, instead of being at 1, is going to be at 2. This point right here is going to be at -2, +2. The zeros will still be at 0. So I'm going to get a different color, And I'm going to go through and I'm going to make these go higher and lower. So I'm still going to go through the point 0. You want to make sure that you remember that this is a curve. It's not going to have jagged corners or sharp edges or anything. It should look like a nice gentle curve. And so as you're doing this and as you practice, like try to make that nice and smooth and a nice curve and not like sharp corners like an absolute value graph. Okay, now in the next section, I've got this question, what should you label your x and y axis? And so I have labeled the y-axis here because those aren't really changing for any of the ones we do, but it could be like maybe I would leave that off and let you decide. So maybe if you had an amplitude of say 5, then maybe you'd want to call this, 2.5 and 5 or something like that. It just depends on what you're given. If I'm leaving this blank, that means that I'm letting you decide how to do that, and there could be variations. So when you check your homework or something, if it looks different, check and see if we did a different scale, because that could make a difference in how it looks. It's not going to make a difference on what it means, but it could make a difference in how it looks. Okay, let's look at this next problem right here. There's a lot of things going on here. There's actually 3 transformations that we have to concentrate on. Going from left to right, we have first a reflection. Then we have amplitude. So it's going to be stretchy. And then we have a period change. Now when that period change, when that's a fraction, that's where you have to be super careful. So I'm going to put a little star right there because when you have like 1/2 theta, that's where people get really messed up because it's kind of contrary to what you might think. So when you do this, my recommendation is take care of the period change first. Then do your amplitude. Reflection would be the very last thing because it's the easiest to see, and so you want to do the things that are hardest first so that you're not trying to make everything more difficult. So the first thing is do a parent function. So I'm going to get my pencil and I'm going to do my parent function of cosine. So remember that cosine is going to be at +1, and then we're going to go down. Now I am operating, you might want to hold on just a second, maybe don't draw it, let me just talk through it for a second. If I do this, then that's going to be exactly the same scale as I had in previous problems, and that's fine. Okay, you do need to, if it's not labeled, you do need to label it. So I'm going to label mine. And like I said, you might want to just hold on and see what I'm doing first before you decide that that's what you want to do. Actually, that's pi halves. Okay, so something like that. So you just need to make sure that you've labeled it so that whoever's looking at your graph can tell what's happening. Okay, and so if you're going to skip one. Now let me show you other things you could do is you could label it differently. Like maybe you want to say that that's pi halves and that's pi, and then move everything so that it's closer. If you did that, then what it would mean is it would mean that you would have to, since this is pi halves right here, that's where you're going to have to be at 0. So you're going to have to go to 0 and down and then back up like that. So it's not really compressed, it's not really squished in horizontally, it's just that your scale is different. And so depending on what you're doing, you might want to do that. I'll show you some examples though. For this one, because I know what's going to happen, let's do a different scale on here. So now you can draw this. Let's adjust our scale. So just because I kind of know like what's going to happen here, let's go ahead and call that one pi halves, pi, 3 pi halves, 2 pi, 9 pi halves, 5 pi halves, 6 pi halves, which is 3 pi, 7 pi halves, and then 8 pi halves, which is 4 pi. So we're going to do that. And then it would be exactly the same on the other side, except just negatives. Okay, Okay, so like that. Now the reason why we would do that is because of the period change. So let's look at what does that mean. So remember that the period, the standard is 2 pi. If that number, or b, if it's different, you have to divide 2 pi by that number. So 2 pi divided by 1/2, that doesn't mean 2 pi divided in half. It's 2 pi divided by 1/2. So divide by 1/2 means multiply by the reciprocal. So what our period is 4 pi. That means that instead of completing an entire cycle in 2 pi, like if you go back to our, let me see if I can get to, if we go back to our parent function, it took from 0 to 2 pi to complete one whole cycle for that. And so instead of doing that, it would only complete half a cycle by that time. It would take from 0 all the way to 4 pi, which is off my page right there, to complete all the way through that cycle. So it'd be really stretched out. It would be like, so more stretched out like that. That's what we're going to be doing here. So what we're going to do is we're going to take twice as long to do everything. So instead of being at 1 and then at pi halves, we're down at 0. So let's do the parent function actually. We'll do the parent function first. So 1. Now keep in mind that this next one is pi halves, and so that's 0. So instead of taking 2 squares to complete everything, we've squished it like scale-wise so that it's 1 square. So it's going, our parent function okay, that's our parent function. Now with the period change, it's going to take twice as long. So you see where it took from here to complete our entire cycle. So down and then all the way back up, that's an entire cycle. We're going to take twice as long to do that. So instead of taking 1, 2, 3, 4 squares to do it, we're going to take 8. So instead of going from 0 here, or sorry, 1 to 0 in 1 square, we're going to take it in 2 squares. So I'm going to start with this, and I'm going to go to 0, take 2 squares to get to -1, take 2 squares to get to 0, take 2 squares to get to +1. So I'm going to take that long. Now you might think that's exactly what we did on the previous ones. Yes, but look at what our scale is. So our scale, I think I might have mislabeled this. I did mislabel it. So that's not good. So we've got 2 pi is 8 halves. Let's see, 4 halves, and then this is 5 halves, and then 6 halves, which means this is 3 pi, and 7 halves, and then 8 halves is 4 pi. The reason I knew that is because I knew it had to complete an entire cycle in 4 pi, and I had too many squares, so that's where I messed up. Sorry about that. This is off too. Okay, some of you might have already caught that I did that, but now it's corrected. So continuing on the other direction, we're just going to be going like this. And so that would be the period change part of this. I actually want to undo my highlight because that's not my final answer because I haven't addressed the other things going on here yet. So taking off that highlight. Okay, so the next thing that we're going to look at is we're now going to look at the amplitude. So the amplitude, that's not that hard to do. You're just going to make it twice as stretchy. So what I like to do is I like to put my points so I can kind of guide my drawing. So I'm still going to go 0. And so every time I go through 0, I'm still going to go through 0. But I'm going to go twice as high and twice as low, like that. The last thing that we're going to deal with is that reflection. So the reflection, I'm just going to take like this point right here is going to be reflected, so it's going to be right there. This point is going to be down here. This point will be up here. This point will be down here. And so I'm still going to go through 0, but what I'm going to be doing is I'm going to be going up and then down and then up and then down. So I'm going to be just opposite of what I was. So you can go ahead and pause and do that. So you can see what I mean by having a lot of graphs going on in the same thing. And so if you're turning this in, or if you're having this on a test, or if you're showing somebody, you look at that and you're like, oh my gosh, what is happening there? So it's really important that you highlight your final answer. This is my final answer. This is what the graph of -2 cosine 1/2 theta looks like. So make sure you highlight it so that we know what our final answer is. I don't want you to draw this and then erase everything else, because if you do that, if it's like on a test or a quiz, I cannot give you partial credit. If you messed anything up, I can't give you partial credit. If I see nothing that you did, I can't see where you messed up. I can't see, well, besides this thing, you did it all right. So you need to show all of that. That's all your work. Okay, the next one we're going to do, there's no amplitude or reflection, but there is this. So that's a period change. So we're going to decide, what does that do? So you might think, oh, well, it's going to be 4 times as much. Well, kind of, in a way of thinking about it. What you're going to do is you're going to do 2 pi divided by 4, and that's pi halves. What that means, it means your entire sine curve that goes like this, that's all going to happen within from 0 to pi halves. So in your unit circle, from 0 to 90, like you're going to go all the way through the whole cycle in that much time. And so we're going to squish it. It's going to be squished together. So you can do like the standard, that what we did before. You can say this is pi halves, and this is pi, and this is 3 pi halves. But then what that means is, it means you have to, from here to here, you have to do the entire up, down, and back up again, which is fine. You can do that. You could label it differently, though. You could say, I'm going to say that this is going to be pi halves. So this will be pi fourths. And this will be 3 pi fourths. And this will be 2 pi. And so I've just kind of made it a little bit easier, because I have from here to here to get through the whole thing. So I can go up and then, up and then down and then back up. So I have a little more space to draw that in there. So it's either that, or if I did it the other way, I would have to go up, down, up like that. It's the same thing because it matters what your scale says. So you have to label your scale. You can't just assume that everybody knows what you're talking about. You cannot do that. So I'm going to go ahead and leave it how I have it. You are welcome to try something different if you want. And on your homework, you'll have a couple of opportunities, if I remember right, that you're going to need to decide what to scale. So you want to do something that works for you. Parent function first. So the sine curve, that's through 0. And that's like the main thing I remember, is I just remember like it's through 0. Now my parent function, be careful, because you're not doing, this that we did on the beginning, because our scale is different. So our parent function, it's from 0 to 2 pi, and so that means that I've got from here to here to go up and down and up again. So the halfway point is at pi halves, so I'm going to go up and then down and back up. So you want to split it out so you know like where everything is, and then it'll be the same thing the other direction. So you just have to be mindful that you're not just going to carbon copy whatever you did above there, like as your parent function. You have to be mindful of what your scale is. Okay, now I'm going to change the period, so everything's got to be done within pi halves. So from here to here, you're going to go up, down, and up again. So I'm going to get a different color. I'm going to go up, down. So what took 4 squares is now going to take 2 squares. And so before, you'll notice like from 0 back to 0, it took 4 squares to do that. But now it's only going to take 2. And so I'm going to go like this, and then up, So you'll get a couple of periods or cycles in this graph. Okay, so that's how, oh, whoops, I didn't mean to erase that. So that's how we're going to do that. So your entire thing is going to go in pi half. So when you have a bigger number right there, it means it's going to be compressed or squished in horizontally. So it's going to be like this. It's going to go in pressed horizontally together. So you used to be able to get in 2 pi, you could get 1 cycle, but now you can get 2 cycles within 2 pi. So anyway, like I said, just be mindful of what your scale is and make sure that you take that into account when you're doing this. That's all that we have on this one, so I can highlight that as my final answer. Okay, now this next one, this is probably the hardest one here, because when you have something like an odd number that's affecting the period on that, that's going to be a little bit trickier. So the period on that, you're going to do 2 pi divided by 3. So 2 pi thirds. So think about your unit circle. Let's see, where did my unit circle go? I don't know where it went. Think about your unit circle. And 2 pi thirds, that's, you know, from there to there. You got to get like basically the whole thing within that space. And so you're going to be going up, down, up again, all in 2/3 pi. So what you can do, and it's not really a cheating way to do it, but it does make it so much easier. If you want to just draw your parent function with your standard scale, whatever it did, like what we did at the very beginning. And so if I just go like this, I'm going to go just, you know, down and then up, like that. Okay, that's my parent function. And then what I can do, because there's no other changes here, there's no reflection, there's no amplitude, there's nothing else I have to consider. What you actually can do is you can say, well, since I have to do the entire thing in 2 pi thirds, the entire thing is like from here to here, just call that 2 pi thirds. So this is 2 pi thirds, which would make the halfway point pi thirds, which would make the halfway point of that pi sixths. So this would be, so 1 pi 6, 2 pi 6, 3 pi 6, so this is pi halves right there. And so actually your parent function turns into your final answer because you just adjusted the scale. So that's not something I normally want you to do or encourage you to do, but on something like this, that's really like the smartest thing to do, because it's kind of hard to get a period of 2 pi thirds when you're used to dividing things in half. Okay, the last thing on the notes is just make something up. We don't want to get too wild and crazy, but if we just make up some kind of a function. So I want you to make up something. Just write something that has, let's do something that has everything in it, but let's keep it kind of simple. So you can choose, do you want to do a sine curve or a cosine curve? I want you to say y equals, and then I want you to give it an amplitude, and then either sine or cosine, so whichever one. Okay, and then let's do a period change. So you pick a number that's going to go right there, and then x, and then let's do a +1. So go ahead and make something up. You're going to want to pause the video and try it, and obviously what you make up is probably not going to be what I make up. So come back here, we'll talk about what I make up, and then we're going to go back and talk about range on all of these. Okay, this is what I made up. I tried to keep it fairly simple, but have some differences in it. So things to notice, it does have, oh, I wanted you to do a reflection too. So it's got a reflection, it's got amplitude, so it's going to be twice as high. It does have this period change, and this one's different. It's got a vertical shift. So I still recommend that you do this part last, the reflection, like do that last. I also recommend that you do this second to last. I still recommend doing the period first. So let's go through all of this. So if I ask you what the amplitude on this one is, it's going to be 2, not -2, 2. If you're asked what the period is, be careful. It's not 2 pi divided in half, so it's not pi. It's 2 pi divided by 1/2, so it's 4 pi. Now, we're going to go back and talk about the range for all of these, but for right now, let's just do this part. So my parent sine curve, I'm going to just do what I showed you in the last one, because when your period is taking up a lot of space, you may not even get a whole cycle in your graph if you're not careful. And so it would probably be good, especially because we have a lot of things going on. I'm just going to say, since I have to do the period in 4 pi, if I'm doing sine, I'm going up, down, and up again. So I'm going to make this 4 pi right there. So if this is 4 pi, then my halfway point right there, that would be 2 pi. And halfway between that would be 1 pi. And so that makes it kind of easy to just mark that out and have that set up. So like I said, I don't want you to do that every time, but on something like where we have so many things going on, that's not a bad idea. Okay, the next thing that we're going to do is let's do our vertical shift. We haven't seen one of those yet. Just like any other function that you have, that's just going to lift everything 1. So instead of being here at 1, it's going to be at 2. And so everything's just going to come up 1. And so take a minute and just go through and move all your points up 1, and then that will help you draw. And then you can go through and connect. Like that. Okay, now the next thing is we have an amplitude, and I didn't actually think this through very well before I made this problem up, I guess, because if my amplitude is going to be 2, then instead of being here at 2, I've got to be at 4. So I'm going to have to go way up here. This one will be it's going to go, instead of being right here, we're going to go twice as far down. So basically it's going to go from, well, our halfway point will be like right here. So this becomes like an imaginary axis if you want to think about it that way. I'm not going to actually draw it because that gets more confusing. But we're going to go like this. Whoops. Like that. So my amplitude is 2, because if you look at from your, midway point. So from your high point to your low point. I did that wrong. Since your amplitude is at 2, when we've already shifted it up, we have to be careful that we consider this. So my graph right now, if I look at from the high point to the low point, it's 2 squares like that. That's an amplitude of 1 because it's 1 from the top, 1 from the bottom. So now my amplitude is going to be 2. So I'm going to have it go 2 units to the top and 2 units to the bottom. So my high point is going to be at 3 because it's just going to be, instead of here, it's going to be up 1 more unit. And my low point, instead of being there, it's going to be down 1 more unit. Sorry, I didn't mean to have that. And so it's going to be going like this. Okay, so then if you look at, the change from your, let me get some different colors here. If you look at the change from your high point to your low point, that's a distance of 1, 2, 3, 4. So your amplitude is half of what that distance is, and so that makes sense. So if I go to highlight my final, oh, I haven't done the reflection yet. So next needs to come the reflection. And so what I'm going to do now is I'm going to take this point right here, and it's going to be reflected. So again, like, look at this as being your axis. That's where it's going to be reflected across. So it's going to be, instead of above 2, it's going to be below 2, like this. And then high point changes to low point. So that's just how you can think about it. So if I get my color, I'm going to go from here, high point, low point, high point, low point. Okay, and then that's my final answer. So I'm going to highlight that as being my final. I'm going to go back and talk about range. So let's go back to the beginning. Now when I talk about my range, that's my high point to my low point. So here I would say that my range would be from -1 to 1. Or you could say not x, sorry, that should be y. You could say y is an element of from -1 to +1. Okay, that's the high point and low point. Same with cosine, it has the same range. So this range would be from -1 to 1. Now when things start getting a stretch, that's when it changes. So here it's going from +2 down to -2. So -2, +2. So you would say that the range on that one is -2 to +2, or you could say y is an element of -2 to 2. This one's going to be from -1 to +1. This one is going to be from -2 to +2. This one is going to be from -2 to +2. This one is going to be from -1 to +1. So usually your amplitude can help you, but if there is a vertical shift like we had on this one, that +1 changes it. So you want to be really careful about all the things that you're doing, but you're going to have a low point of -1 and a high point of 3. The distance between them should still be 2 times the amplitude. So from -1 to +3, it's still just 4, which is twice what 2 is. So we're going to say the range on this one is from -1 to 3, or you can say y is an element of the interval from -1 to 3. So on your quiz, on your test, you'll be answering questions like, is there a reflection? What is the amplitude? Make sure it's always positive. What is the period? Is there a vertical shift? Is there a phase shift? So remember, phase shift is like this one that we saw right there, where it goes left to right. What is the range? The domain I may not ask you because it's always all real numbers, so that's not really that exciting. But those are the main questions that I'll be asking you about that.